Hello friend, this video is part 3 of microservices tutorial. In first video, we discuss monolithic and microservice application and their architecture with example in detail. In second video, we created a Spring Boot application from scratch. If you haven't seen those videos, please go ahead and watch them first, then continue with this video. One request from my side to you to please like and share this video and do not forget to subscribe the channel. Based on this microservice architecture, which I have already discussed in first video of this tutorial, I am going to create our first microservice student. In next video, I will create second microservice course, and then I will create API gateway and service registry. For student microservice, I am going to use MySQL database, language Java, and I'll keep application name for this student service as student underscore service. I'm going to use Spring Boot framework for this. So guys, for our first microservice, we will use the same application which we created in last video. So this was the structure for that application. We created one controller for a student, and here it was the model for this student. This was the service, and here it was the service implementation. So usually here we were just creating a dummy data and we were just printing. But now we will store this data in database and we will fetch data from the database. Okay. So let me first of all create database and create a table for a student. Let me open MySQL Workbench. You can use command line also. Here I am logging as a root user. You can create your own user, give permission and privileges, then use that user to create database. I'll create a database. Name I will give database db underscore student. Okay, select it. Okay, database is created. Now I will create one table student in this database. I'll copy paste. So here you see I created one ID. This is auto incremented. It will be as a primary key. Then second column is name. Third column is mobile number. And fourth column, I added one more column, which is course ID. So this ID will be a primary key for the course microservices, which we will create in a next video. But now only I'm creating here so that we can use it later. Okay, so let's select and hit okay. So first we have to use database, use db underscore student, click use, and then again run this. Okay, so our table is created. Let's do select string from student, and we will not having any database. Okay, fine, perfect. Now since we added course ID there, so we have to add here also one integer and course ID. To use database in MySQL, we will use Spring Data JPA. And so we need two more dependency, POM dependency. One is for Spring Data JPA and another one is for MySQL. So let me add those in our pom.xml. Here I will add that one. Let me quickly add that. Okay, so here we got our two dependency, Spring Boot starter data JPA and MySQL connector Java. Okay, that's it. Let's save it. Once we will save, it starts downloading all the dependencies, this JPA dependency and connector to our library. Next, what we have to do, we will use this same student class, this model class as an entity. So in Spring Boot data JPA table, in Spring Data JPA, we call table as entity. Okay, so what we have to do, we have to annotate it with entity, entity, and another annotation will be table. Let's okay, done. Okay, we can give name also, like name equal student. That we need to give whenever our database table name and this entity name is different, then we can give it. Otherwise automatically it takes the same class name as a table name in a small letter. Now whichever key we are going to map with the primary key in database, we have to annotate with id, at the rate annotation id. At the rate annotation ID is inherited from javax.persistent.id, and it indicates that the below is primary key for current entity. Now we have to provide the generation strategy for primary key value. So here we have to annotate with generated value, at the rate generated value strategy equal generation type dot identity. Let's import the package. Generation type we can give auto, identity, sequence, or table. So when we are giving when we are using default generic type auto, then for persistent provider will determine values based on the type of primary key attribute. This can be numeric or UUID. When we use identity, which I am going to use it here, it relies on identity generator which expects value generated by a primary column in database, meaning they are auto incremented. If we want the column name to be different than the key name here, then we can use annotation at the rate column, and then we can provide a name. Like if we want column name to be mobile underscore number. So if there is any case like this, that key name is different, mobile underscore and O, but we want database table column name should be mobile underscore number, then we can specify like this. Otherwise, it automatically generates from the key name here. It will be for this mobile NO in database, it will be like mobile underscore NO by default. Okay. So we use at the rate entity annotation, we use at the rate table annotation, ID, and at the rate column. So at the rate entity annotation defines that a class can be mapped to a table. It's just a marker. Anything else is optional. For example, table name is derived from entity class name. So at the rate table annotation can be optional. Tables column are derived from entities variables, and therefore at the rate column annotation can also be optional. Let's import the packages, and this is done. We are done here. Now we have to create the repository interface for this student entity. So let me create interface. I'll keep a different package for this, com.code.repository. Interface name I will keep student repository. One thing we have to be very careful that this repository name should be entity name, then we have to write repository after entity name, otherwise it will not recognize that. Now here we have to extend with JPA repository, and we have to provide the entity name which is student and the primary key data type. Here we have integer. That's it. JPA repository is JPA is specific extension of repository. It contains the full API of CRUD repository and paging and sorting repository. So it contains API for all basic CRUD operation. If we go inside, we can see it has find all, and then we can sort also, find all by ID, save all, save and flush. So it has all basic CRUD operations and pagination and sorting. operations as well. Okay, that's it. So we created our student repository. Now let's move to service implementation. Now we have to use that repository to save data in database and get data from database. So to use that, we have to annotate that with auto-wired. Auto-wired student repository, and let's keep the same name. When we use @auto-add, Spring Framework enables automatic dependency injection. So whenever we need an instance of any bean, we have to annotate that bean with @auto-add. Now we have an instance of a student repository, so we can use all the basic CRUD operation from JPA repository. So for here saving, what we have to do, I'll disable this and I will just say student repository dot save, and I will pass the same student object. That's it. Now this student object will be saved in student table by this method student repository dot save. Now we want to get student details using ID. So what we can do, we have to do, I'll remove this, and we have to use the same student repository dot get one, and or we can do find by ID. Here we can pass ID, and actually it returns optional. You see, it returns optional value. Okay, so we can write here like else or else null. So if this ID doesn't have any value, so it will return as null to student as, and then we are returning this student. Similarly, we have to find the student using name. So in that case, we have to do the same student repository dot find by name, and we have to pass here name. But you say this is giving error. This is by default method given by the JPA repository, but this is not. So we have to write this explicitly to this student repository interface like this. The return value will be student and find by name string name. That's it. Okay, now the error is gone. So all is fine with our student service implementation, and we don't have to do anything here in controller. Now we have to provide the connection from our application to database. So for that we have to specify data source URL, data source username, password. So for that, what we have to do, we will write those things in our application.property. So let me first change the name of this application.yml. I will use the YML, rename. So in YML structure, it shows you like parent child structure, so it's very easy to understand in that. Done. Let's go inside this. I'll copy paste and then I will explain. So here I have used Spring application name. This is the name for our microservice, student microservice, and now from here I'm going to use the database related things. So you see the hierarchy, data source. So there is a proper space. It is like spring dot data source dot URL, then spring dot data source dot username. But for this, it will be like spring dot JPA then dot properties. Okay. So to connect to database, we have to provide URL, username and password. You see, I have given a name like this, dollar curly braces data source.url. That means I am expecting these values from a property file. So that property file I will create in a minute, and so that means that property file is existing somewhere else in your system, and you are using that here. The value will be used from that property file. Here, this is the data source dialect. If we use show SQL true, then whatever SQL query will be executed, it will show on your console. And here is one more important thing is Hibernate DDL auto. So the hierarchy will be spring.jpa dot hibernate dot ddl under this hyphen auto, and it has many values like update, auto, create, and create drop. So the value create, drop, validate, and update basically influence how the schema tool management will manipulate the database schema at the startup of the application. When we use update instead of none, whenever we add any new column or any constraint, then it's automatically added to database table. But when we remove any column or constraint, then it does not remove from the database. Okay. And in the same, so for example, the update operation will query the JDBC drivers API to get the database metadata, and then Hibernate compares the object model it creates based on reading your annotated class and will attempt to adjust the schema on the fly. So that's why whenever you are adding any column or constraint, it automatically adds to the database also. But whenever you remove it, it doesn't remove from the database automatically. So it's not recommended to keep DDL auto as update in production. So the other value is create drop. So when we use create drop, then on every session factory, the startup of the application, it recreates the whole schema with empty database, and at the end of the session, it drops the schema. So this we can use for the test purpose. In test, what we do, we generate some mockup data and then we test it, and then we want the data to be flushed. So in that case, we can use create drop. Another DDL auto value is create. So this creates the schema necessary for your entities and destroys any previous data. Another one is validate. When we use validate, it validates that the schema matches and ID does not make any changes to the schema of the database. When we use none, the one you are seeing here, no action will be performed automatically by Hibernate to database schema. So the recommended is on production. Production you should keep always none, because usually we do our job in application and then there is a DBA to handle the databases. So we give them whenever there is a change in table, and also we give them the script, table script, and they run from their side. So we don't want Hibernate to update those automatically. Now I have to get all these values for these keys from the property file. So let me add these values in the property file. Here I have created a property file, see, student, and the extension is properties file. This is existing in C users admin and then microservice folder. Okay, let me go inside this, open with Notepad++, and I will copy paste this configuration. So this is the MySQL database configuration. You see, first is data source.url. Data source.url. This is what I will get from here. MySQL, I'm running on the local host, so it is localhost, and I have given the database name as db underscore student, right? When we created here on the MySQL workbench, database name was db underscore student. So same name has to be here. And username, I am using root. This is my password, and this is the dialect. So for each database, you have to specify the dialect as well. So these are the configuration file from which the data is getting loaded here. Now to use the configuration file, we have to mention the file location in main class, main method class here, where we have @Spring Boot application. So let me copy the annotation for that. And with that, I have to add the annotation to scan the repositories identities, because you see last time we added this Spring Boot annotation in a different package. That's why we have to add it explicitly. Okay, so I have added entity scan, enable JP repository, and properties source. So this is the annotation for locating the any property file. Here I have given property source and this is my location. This entity scan is scanning all the entities from this package, and JP repository is scanning all the repository from this package. Okay, if we move simply this Spring Boot application to a parent, this com.code, then we don't have to use this one. I'll show you later on those things also. Okay, now that's it. We have added our repository, we added our entity, we added database related things in the property file, and now we are able to access the property file with this annotation. Now the time is to run the application and use it. Now I will run the application. Right click on Spring Boot, run as, and Spring Boot app. Let's see the console, what it is saying. Finishing. Okay, started Spring Boot application, and Tomcat is started on port 8080. So we can access this application on 8080. Okay, so first thing what we will do, we will insert some data for a student. I'll use Postman for that. So I already have this URL 8080 student and save. See, this is the same URL we have to use because our controller says that it should come with /student and then /save. Then it will go as a post mapping. So HTTP method should be post, and it will take the data, data, student. You see here we are using student service to access this method, and we have annotated with @autowired. So since we wanted an instance, a singleton instance of a student service, so we have annotated that with @autowired. So Spring automatically inject it here. And Spring uses JSON, so whatever is coming as a JSON, it automatically converts to the object. Okay, if the keys are matching, so automatically it binds with the object. So let me use, now we don't have to pass ID because it's auto generated, so we'll omit that. Name, let's keep John, and mobile number, let's keep like this. We'll add course ID because we have course ID also, course ID. Let's keep value like 1. Let's hit true. Okay, insert into student course ID, mobile number, and name values this. Okay, now if we go here, student service, student mobile number, you see we have removed this one. There it was @column, and the column name was mobile_number. Okay, so I removed that one because we in database we have mobile_number. That's why it was not required. Now you see because of this y.xml SQL is equal to true, we are able to see in these queries insert into student and this query in the console. Now since we added one data, we got the result as true. Let's see in the database. We'll query in database, select a strict from here, and here we have the first record 1 John and these values. Let's add few more records. I'll add Ramesh, change this one 1 2 3 5 6 7 8 9 10. Let's add 2, hit again, we got true, and let's check in database, query again. Here we got the second record. Now what we have to do, we have to retrieve that through ID. We will pass this slash student slash ID and we'll pass the value ID. If you're not passing anything, then by default it will take a 1. Then it will go here, get by ID, and we have said that query the repository with find by ID. Okay, so this query will be something like select strict from student where ID equal whatever value we will pass, like this. It will query like this. Okay, let's see. So I'll use a different URL, student ID slash ID equal 1. Let's hit it. Here we got the record ID 1, John 1, and this is the value. Now let's hit 2. Here's the record. So this is also working. We have one more, get by name. So here we added get by name. Let's go there. What it is happening? Sorry. Okay. So when we call this one slash student slash name, it will call this method from service implementation and it will fetch the details by name. Let's see here. Change this value. We'll say name equal John, and here it was name. Here we got the details, right? Second one Ramesh, it we got the Ramesh. Now what if it is not there, then what? Let's say something tweet. So you didn't get any records. That's fine. Similarly, we can add other method also, like for update, for patch, and for delete. That's all for this video. In this video, we created a student microservice. In next video, we will create course microservice with different database. Please like and share this video and don't forget to subscribe. Click on bell button to get notification for the upcoming videos. Thanks.